A series circuit, we have two types. We have a series and a parallel, and the series is the first one we're going to talk about. The voltage is divided among the devices, and this is when the current only has one path to follow. So if you see this, you see the current is going here, it's going to go through the two light bulbs, and then it's going to go to the negative side. When you see something in your textbook that says the current is going through, and they'll say current through, that is something to let you know that you're talking about a series circuit. In a series circuit, because there's only one path, if this bulb goes out and it won't light anymore because it's gone out, the fuse is blown or whatever, this bulb will also go out even though it still works because the current can't just jump over the other bulb. So a lot of times you'll see this with like Christmas lights. You'll have a whole bunch of lights in a row, and if this one goes out, they're all dead. New Christmas lights don't work that way because it was really annoying because you would take a bulb out, try it, take a bulb out, try it, and you'd have to go through the whole thing of lights before you could figure out the one that was dead and replace it. When you are using a series circuit, each light bulb makes the brightness get less, okay, because that current is having to share. Each light bulb's having to share. So 2 light bulbs will be half as bright as 1 light bulb. 3 light bulbs will be 1/3 as bright as 1 light bulb. And so to figure out the resistance of a light for a series circuit, to get the net resistance, a lot of times they'll just call this the R. They use the resistance of the first thing plus the resistance of the second thing. And then to calculate the current in a series circuit, whatever volt you have, that'll be on your battery, you'll just divide that by that net resistance. And that'll give you the current in the series. So let's try and draw one. So they want us to draw a circuit diagram that has a 60-volt battery. So I'm going to go ahead and I'm going to just do this. And again, physicists aren't amazing artists, so you don't have to worry about being like the most beautiful drawing you've ever seen. You have a 60-volt battery. You have an ammeter. So that's that A with the circle. And then you'll have a line connecting the two, and then a resistance. And I like to make my resistors on the top. I don't know why you don't have to. So we have our battery is 60 volts, and we have our resistance of 12.5 ohms, and then the direction of the current, remember, is going from positive to negative. So your current's going to go like this. And that's all you have to do for this. That's all you have to do to draw a circuit. And these are in series because they're right in a row. Now, let's try this one. They're going to give us some math. Now we have 2 resistors. We have 47 ohms and 82 ohms. So I'm going to go ahead and I'm going to draw my resistor. Here's my first one. I'm going to call that A. And then I'm going to make a second one. And I'm going to call that B. And then we have a battery. So usually I put the battery on the bottom and the resistors on the top. Again, that's just something I do. It doesn't really matter as long as both your resistors are in series like they said. And then I like to put the numbers of the resistance on top of each resistor. I'm just visual that way. And so now we want to find the current in the circuit. So the first thing you have to do is you need to find that net resistance, which is the resistance in resistor A plus the resistance in resistor B. So you'll take that 47 ohms and you'll add 82 to it, and you should get 129 ohms. And now that you've got that, you can go ahead and you can find the current. And remember, the current is just your your volts of the source, that's your battery, divided by that net resistance. Okay, so you're going to do 45 volts divided by 129 ohms, and you're going to get 0.35 amps. And that's all you have to do for this one. Now, let's go one step further. So now they want to know the voltage drop across each resistor. So all they want in this one is they want the volts for each individual resistor. So for resistor A, remember your ohms are 47, and your volts are still going to be 45, and your volts will be the same for both resistors because they're both attached in series and they're both attached to the same battery. Okay, so to figure out the voltage drop or across each resistor, you're going to find the volts for resistor A, and you're going to take your current and multiply it by your resistance. So this is the volts of your battery, and you want to find for each one. And so you're going to take that current that you found before, that 0.35, and you're going to use that in your equation right here. Okay, so then you'll have 0.35 amps and you'll multiply that by resistor A, and you'll get 16.45. And that's the voltage drop across the first resistor. Now to do the second one, you'll do exactly the same thing. You'll do the volts of B, and you'll put that same current in here, right here, except you'll multiply by resistor B. This should be 28.7. And if you want to check your work, you can add these two up, and they should add up to 45. Okay, so that's all you have to do to find the voltage drop across each resistor, is use the individual volts and resistance. For the next one, they're saying the same two resistors, but we're going to replace that 47 resistor by a 39 resistor. So now resistor A is 39 and resistor B is still 82. We still have our same battery. It's still going to be 45 volts. Okay, so we want to know if the current's going to increase, decrease, or remain the same. Okay, so again, to do this, the first step is you have to find out that net resistance, and it's going to change because our resistor A changed. This one's B. So we're going to get 121 instead of 129. And then you're going to use that same formula where you use the voltage of the source, that's your battery, and divide it by your resistance. And so in this one, you're going to have your volts will be the same, but the thing that you're dividing with down here is smaller, which means this number up here is going to be bigger, so your volts or your current is going to increase. And when we actually do the math, we see that it's 0.37, and before it was 0.35, so it's going to increase. Now, the two resistors are connected in series, and the 47 resistor is replaced by a 39 ohm resistor. What is the new voltage drop across the 82 ohm resistor? So all they want to know is the 82 ohm resistor. So we want to know this. We have our resistance is 82 ohms. And then our current, instead of being 0.35 like it was in the earlier one, it's going to be 0.37. And then we're just going to use our volts are equal to our resistance times our current. And this is going to be the resistance of B, not your net resistance, but we're going to use that net current. So we'll have this 82 ohms times 0.37 amps, and you should get 30.34 volts. So the last time this resistor had 28.7 volts, but now it has 30 because the resistor A got smaller, and so it used less of the volts. And so this is how you solve these circuit problems. Try your homework. And remember, try and draw these circuits, and you're not going to get a list of what each thing is. So you should know on your test that that's a resistor or that that's a light bulb. We're not going to tell you that. That's something that you should know. So make sure you know those. Make flashcards or whatever you need to do to know those things.